Hello everyone, this is Amit, and today we would be peeking into a library that is called as Matter.js. So this is the particular library that it is. This is Matter.js, and this particular library is, very. I mean, it successfully emulates the behavior of physics into the day-to-day scenario. So let's begin. Okay. So first of all, we would see how can we emulate what are the different characteristics that can be emulated using this particular library. Okay, so first is called as this air friction. So air friction can be very easily emulated by it. Okay, this is what air friction is. Let's say if I want to change the direction of gravity, I want to add an X factor into it. Now all the boxes would start moving towards the right direction as if so its origin is coming from here, and it is somehow having an x-axis and a y-axis with it. Okay, this is what it is. This is what it is happening over here. Now coming to the other scenarios, coming to the other scenes and scenarios. So let's begin. Now, if we see that was air friction, now comes the avalanche part. What if the gravity changes? See, so these are the components that are there available in the Avalanche. Apart from Avalanche, we have ball pool. So ball pool, what it takes, these are the balls, these are set of balls that we have, and that would act like a pool over here. So if we try to decrease the gravity, if we try to increase it, it would be still like this. Try to decrease it, like this, like that. Try to increase the X factor over here, it would act like this. Okay. Now this, what if I decrease the scale? What if I increase the gravity? What if I increase the scale? So magnitude would also get increased. So there are a lot of things that can be done. Okay, ball pool. This was ball pool. Now coming to the bridge. Bridge can also be emulated in it. Okay, this is quite powerful library. So an avalanche, a bridge, or an air friction can be emulated into it. Coming to the cars part of it. So we have cars in it. So the car can also be emulated. So we are given this particular car, and this is the moment which is happening in it. So this is from left to right, right to left, so and so and so and so forth. If you try to move from left to right over here and from right to left over there, now we try to do the same for this particular car. Now, if we have, let's say we have a catapult. This is how the catapult would behave, like this. Okay, so we have a lot of boxes over here. We just want, okay, this is so perfect here. I mean, who have made this? So there are a lot of contributors in this particular library. Coming to catapult, we have chain. So this is how the chain works over here in it. This is how the chain works over here in it. So there are a lot of chain factors that are working in it. Like this, like this, like this. Okay. So this is how it is working. So that's how we would keep a track of all the simulation that is happening under it. First, then comes the clothes part of it. Clothes can also be emulated into it. This is what the clothes would look like. This is what the cloth would look like, and this is what it is. Okay. Now coming to collision filtering. Okay. So let's say I remove this and I put the ball over here. Okay, so there are few balls through which it would pass through. So I think yellow would be the one. And okay, what if I have a red one? If I bounce on a red one, it would have a collision with it. Okay, got it. Collision filtering, then comes the composite manipulation. So this is the composite manipulation in it. A composite manipulation part of it, we have a lot of particles that are communicating with each other, and though these particular particles, these set of particles are communicating. So this is what is called as composite manipulation. So these composites things are kind of these composite structures are kind of communicating with each other. And coming to compound bodies, we can create compound bodies into it too. This is a pendulum. Okay, so okay, I think that was away from it. We have still lost this. Let's say if I try to increase the gravity, let's say if I would be able to see that particular object. So once that particular object, I think, is out of the plane, you won't be able to see it through. Okay, compound bodies. This is what it is. Okay, this was compound body. Now coming to this, these were compound bodies. Now coming to compound sac. How does the compound sac would work? So this is the compound sac. If we take one of these things, these frisbees, and we hit over the bottom, it would be like this. Okay. So one from the top to the bottom, it would act like this. Compound stack. This was compound stack. Coming to concave. I don't know what concave is. Okay, so these particular objects, so these were like polygons. Okay. So these objects are like polygons, and these objects kind of behave with each other like a polygon. So this is it. This is the polygon, which is communicating with the other polygon in a different way. Concave. This is what concave is. Coming to constraints. So this is a pendulum, and this is yet another spring-based pendulum. Spring-based pendulum. This is a soft one. The other was a soft one. Okay. This is a plank. This is a plank. These are doubly connected plank. These are doubly connected pendulums. These are also doubly connected pendulums. These are also doubly connected pendulums. Coming to the constraints, double pendulum. This is what a double pendulum would look like. And a double pendulum is kind of different. What if I take this? Okay. And okay. So everywhere it is making a trajectory, it would be able to, have a mark over it. Coming to events. Whoa. This is so awesome. These were events, and this library is very optimal into wrecking ball. Wrecking ball. We have a wrecking ball over here. We take this ball and we try to hit the surface. We try to hit over these things. And yeah, we are able to hit it using this particular wrecking ball. Now coming to the view. Okay, this is how the view would work. Coming to the terrain, this is how we can build a terrain over here. Library is pretty much awesome. But the graphic part of it is not good. It is, I think, because it uses CPU, then you can't have a good graphics over here because every time the screen would render, these graphics are also supposed to be rendered as well at the same time. This was about terrain, concave SVG. So what is this? SVGs, SVG, SVG. This is it. This is it. This is SVG. High substeps. What is this high substeps? So there are a lot of part of it. Okay, I'm not able to get it. This is what is called as high substep. Okay, I think this is what is called as high substep. And apart from high substep, we have, stress thing. Stress one was yet another thing. Stress one. Then we have stress two. Then stress three. Stress four. Stress is there. Stress two is there. Now coming to the other. Stress three is there. Coming to the third one, fourth one, that is stress 4. That is stress 4. This is what stress 4 is. Stats and performances. This is what a stats and performances look like. I am not able to understand what stats is this. What is this? What is it? Stats and performances, static friction. Okay, now here what is stack? Okay, we have a different set of stack over here. Okay, sprites. We have sprite over here. We have sprite. This is what sprite is. This kind of sprite, it looks fashionable and white. Sprite. This is what sprite is. This is what sprite is. We take this. We try to take this ball and over the other ball. What if we take this out and take the other ball and take the third one, all these balls over the top of the other? These were stripes. Now coming to the soft body. What is this? So all of these are soft bodies. They try to communicate with each other. These are the soft body. They try to communicate with each other. Try to hit upon the other person, the other soft body. This is the soft body. This is the soft body. Try to hit over the soft body. Yeah, this is what is happening. Coming to the soft body slingshot. What is this? What is it? It is also slingshot. What? This is awesome. Every time I try to use it, There is, yes, yet another hexagon that is coming out of it. So hexagon, yet another hexagon, yet another hexagon. What if, yes. So this was it. This was it. Thank you.